Hi. My name is Yangqing, and thanks for the really warm introductions. I'm actually under quarantine in Shanghai right now, and hopefully everyone is good and staying happily at home or at your workplace. And it's a special times, and I would love to basically first say guys, this year is a special year, and safety is first priority, and it's great that we have the technology that allows us to connect online and still talk about AI and stuff like that. I'm going to be talking a little bit about, with a lightweighted kind of content, talking about what AI is, why do we need AI, and from an organization perspective, why do we need AI and what kind of things we need to prepare for it. So I think if that's not too much prompts, let me share my screen and I'll turn off my my video and let's get started. All right, let me play it. I hope you guys can all see the slide, right? All right, so before we start, I actually want to ask one little cute question, which is, we've all been driving, right? Have you been driving safely? Now, if you think about it, have you ever brought out your phone and look at your text messages and things like that? Have you been speeding? Have you been kind of, like looking around your shoulder when you turn or things like that? Are we an absolutely safe driver? We'll just keep this as a question here, and we're going to be moving on to talk about AI and come back to this topic later. So we've heard quite a lot of things about, like AI. And the first question is, why do we care about it, right? What does it do? What can it provide us? And things like that. From an economic perspective, I would like to basically abstract that as a simple relationship of demand and supply. We need more intelligent algorithms. That's the demand. And we need a smarter way or a more general way to provide such a wide range of intelligent algorithms, which is supply. So let's talk about demand. I'm going to be talking about one little story about, I guess, the ecology, right? We know that globally, corals are dying across the globe. The ocean marine biologists are working really hard to solve that problem. And they have really, really smart people and tools diving down into the oceans, taking videos of the corals of the ocean and try to figure out what is going on. Now, the problem is that it takes a long time to grow a marine biologist, going through a PhD program and things like that. And the vast amount of videos needs what we call annotation, where the corals, what they are, and things like that. Takes a huge amount of time and almost impossible. Now, a few years ago, a bunch of AI scientists, when I was back at the University of California, Berkeley, we worked together with NVIDIA, with University of California, San Diego, to basically deliver a method that allows people to look at the corals, in a more automatic way, and using AI deep learning algorithms to automatically annotate those things. With that, we'll have a much better idea about how the corals are being treated or are growing, and that gives us an easy way for marine biologists to focus on solving the problem of saving the corals. Coming back to the driving problems, we know that let's all be honest, we haven't been driving completely safely or legally. It's not a lawyer problem, so it's not on the record, on the oath. Don't worry about it. We humans are terrible drivers. Right? We have quite a lot of accidents and things like that. And essentially, we need more smart algorithms to help us to drive more safely and in a more varied environment. The picture I'm showing is actually Alibaba's research institutes working on using self-driving cars to do automatic delivery of goods and stuff like that. Essentially, what we are seeing is that, we need intelligent algorithms to go through all kinds of scenarios in our life and not only make our life easier, but make our life, our Earth, a more safe environment. It's to such a dire demand to the extent that a very famous researcher and also pioneer in AI said this: it is the absence of AI technology that is already killing people. Now, we've heard quite a lot of scary stories and things like that about AI, but essentially, if we are thinking about what AI can do for us, such as self-driving cars, and also helping, like marine biologists and things like that, the absence of AI is actually more worrying than having AI, and we have a huge demand in such intelligent algorithms. Now, we have a demand, and economy says we need supply, right? How about supply? I'm going to be talking about another kind of, like more classical, even non-tech related topic. Through the human history, what we have, one big problem we have is the acquisition and utilization of energy, right? Now, in the really old days, how do we deal with energy? If you are lucky enough to live by a river, then you have water mills and things like that to harvest energy out of rivers. If you happen to live in a windy hill, then you use a windmill to get energy out of wind. If you're not lucky enough, you live in like a general rural place, then you have cattle, right? And we basically use cattle to to do the milling and to do the growing crops and things like that. The problem is twofold. One is that we need to design specific tools and specific technology for each specific energy. Two is that it's really hard to transfer and generalize such energy for a global use, right? Imagine if you are living really far away from rivers, your place is not that windy, and it's a little bit hard to, like find grasses and things like that for cattle. Well, then you're in a very hard spot. That has the problem of acquisition and utilization of general purpose energy is one key factor that hinders human development and also sparks the idea of the last rounds of industry revolution. Right now, today we find the general purpose energy for this specific problem, which is, as we all know, electricity. Right. The good thing about electricity is that one, it's a unified solution. Whatever kind of resources we have, wind, hydraulic power, like coals and things like that, we use a unified way to convert it into electricity. And then we are able to basically transfer it really far away or near. We're able to build cities that has a high concentration of energy consumption. And also electricity provides a unified approach for us to utilize it, whether it's TV, computers, networks, like machinery. It's very general purpose. So it's kind of similar in the AI world. If we look at the needs of intelligent algorithms, what we can see is that there's a wide range of applications. Now, to name a few, there's computer vision problems. For self-driving cars, they need it, right? For computer vision problems, what we need to do is to understand what is going on with cameras or video and what's going on in the world. There's speech problems, which is if we're doing, like online customer support and things like that, it's much better for us, for a computer system, to understand what kind of things we human are talking about, and it can interact with us in a more intelligent way. There's also language problems. We have English, Chinese, French, Japanese, German, and Spanish, and quite a lot of languages. And with the globalization, translating between these languages become a very dire need for people. There's also a lot of business decisions, for example, online merchandises, video, YouTube, and things like that. It needs quite a lot of matching algorithms for us to match the content and the interest of a vast amount of people. So all these kind of things, in the past days, we used to basically design specific handwritten, handcrafted algorithms for each of these kind of needs, just similar to the way we deal with water mills, animal mills, and windmills and things like that, which doesn't really scale. For the last round, the really interesting phenomenon that we see is that we are starting to find more and more generalized algorithms, AI algorithms, that can solve these kind of things in a unified way. There's quite a lot of really classical approaches, and I'm not going to be mentioning them, but one method that you've definitely have heard in the last few years is what we call neural networks, or sometimes dubbed as deep learning. Right? I'm showing you a kind of like a block diagram, which basically just looks like quite a bunch of little bricks of different colors stacked together this way to deal with machinery, computers, TV, and things like that. And what we are seeing is that from a supply perspective, AI, or the recent development of AI algorithms, helps us to solve the supply problem, which is it provides a general purpose technology for all kinds of scenarios to use. Now, since we're talking about algorithms, then I'll dive down a little bit into the mathematics of AI, what kind of things we are dealing with today using algorithms. I'm not going to be talking about exact mathematics. I'm just going to be talking about, the overall feeling of it. AI is not really a new thing. If you think about, say, recognizing digits and things like that, Yang LeCun, the really famous pioneer and Turing Award recipient in NEC Lab America, he used to be in, I think, in the 1990s. They've already solved it in some, in a really ancient computer. I'm wondering if I can play this. Sorry. This video is stuck, so sorry about that. 1993. We're already able to basically, look at these kind of amount of data. If you need to teach a self-driving car to drive in a safe environment, not in the deserts with other cars flying around, pedestrian walking around, you need a vast amount of data to deal with it. The good thing is that today, algorithms, data, and compute are basically a organic and natural circle powering AI algorithms and AI applications. Let's talk about data. The last few years have seen an abundance of what we call, well, cutely speaking, data acquisition tools or cell phones, right? And if we think about internet, then the amount of photos that we have or the amount of multimedia content we have is much larger than what we had 10 years ago, 20 years ago. And that feeds a very healthy amount of data into the more and more complex AI algorithms. It's not only larger amount, but also easier to acquire data. Now, I haven't really got my little tools and things with me today, but in 20 years ago, if you really want to have a car that streams a huge amount of videos, it's really hard. But today, with IoT tools and the 5G network and things like that, it's really easy. A self-driving car today probably generates 20 terabytes or even more of data every day when it's on the road testing. And that is basically the fuel that makes AI algorithms much better today. With such amount of data, then apparently a reasonable estimation is that now it needs quite a lot of compute, right? If you were like me and you were taking accounting classes or mathematics classes, you might have remembered buying a Sharp calculator back then to deal with classes. That calculator is not going to be cutting it in today's complexity. The phones that we have today is quite powerful. It's actually much more powerful than the supercomputers that sends people to the moon. But still, it won't cut it when we are facing with terabytes or petabytes of data. Today, what we really need is basically a high-performance computation data center with what we call heterogeneous computing, meaning that we have GPUs or specialized design chips and things like that to deal with the large amount of compute. I'll give you one to train such models, but today, and I'll use Alibaba as an example. In our Alibaba data centers and with scientists working on what we call distributed computation and high-performance computation, we are able to train such a model that surpasses human classification accuracy in 3 minutes. That is basically the amount of computation power that we need to deal with AI. So to summarize the math of AI, essentially what we are seeing is that the new wave of AI or deep learning or machine learning or things like that I've heard about is utilizing the advantage of a unified algorithm and apply it on a large amount of data that we luckily have available today with the help of a huge amount of compute. Now, luckily, scientists have solved the algorithm problem. The development of all kinds of technology, such as 5G and IoT and things like that, have solved the data problem. And engineers, architects, chips folks have solved the compute problem. So we're in a really great time to look at AI and look at the wide range application or deployment of AI. This brings us to the next question, which is, what does AI mean for my organization, right? And I'm a company or I'm a public service agency. How should I prepare myself to embrace AI and use AI in my applications? I'm summarizing this into 3 parts: infrastructure, asset, and people. Infrastructure-wise, I'm going to be talking about asset first. When we think about asset, in the past, we think about, like we think about currency, we think about like real estate and things like that. But today, one thing that is really important is data, right? During our daily operations, we accumulate quite a large amount of data. For the computer vision or the recognizing cats and dogs application that we talked about, I'll give you some perspectives. In the digit recognition thing we talked about back in 1998, the amount of data used to train that method is about 10 megabytes, which you can hold, even with floppy disks, you can hold on one hand. If we want to recognize or train a system that does object recognition in an industry scale, we need about 1 petabyte of data, plus or minus. So that is the key asset. Data has quite a lot of value. Today, when we are looking at all kinds of applications, computer vision, speech, translation, and business decisions, in the wide range of industry or business practices, in industry, agriculture, education, and things like that, we are accumulating a huge amount of data, and those are immensely valuable. You want to protect it, you want to have infrastructure that very well stores them, processes them, and things like that. You might have heard about the terms data warehouse and data lake to deal with either structured business data or unstructured images, photos, and audio, and things like that. Today, we need to look at it from end to end. For each company, I think, for each company and public sector services, we need to put data in our core asset set, and we need to have tools such as data warehouse and data lake to store them. Those kind of data warehouses and data lakes and the tools, the analytical and AI tools on top of it, should be built in a reliable, scalable, and secure way. You're not going to be putting money on the table, right? We're going to be putting it in the safe or in the bank or things like that. And today, essentially, one thing I'm super proud of is that we've been thinking about this problem quite a lot. How do we store data? How do we stream data, process them in a real-time or offline way? And then how do we distill AI algorithms out of that? So we've been thinking quite a lot about a reliable infrastructure that can scale up to petabytes or even exabyte of data. It's highly available so that whenever you need it, it should be there. And then it should be secure, meaning that your data in these kind of infrastructure is as secure as your money is in a bank, because data is valuable. Now, of course, there is data, there's infrastructure, and we need to have people working on it, right? When globalization started, there was this job called translators. Well, today we don't really have too many translators, but that is an essential part of driving the business forward. Similarly, we need people. And I'm going to be talking a little bit about, I'll just skip this page, and I'm going to be talking about why we need what we call data scientists or AI engineers. Now, Andreessen Horowitz gave the world actually one quote saying, "Developers today work with data as much as source code." If you're thinking about the classical software engineer kind of world, then you might have been just like thinking about software, right? And for a lot of companies who are not really dealing with software, then essentially we buy software from Microsoft, Oracle, and the famous and brilliant conventional software companies. Now, the tricky thing about AI is that no one really has a silver bullet that gives you an end-to-end solution very easily and can apply these algorithms onto your data in a black box way. Often we find that we need data scientists, in-house data science that understands your own business. And then those kind of people can solve from the best. And essentially, the conventional software providers or cloud providers like Alibaba does provides a combination of software and also service, infrastructure as a service, platform as a service, and combine these two properties to help you to grow your team to use AI. The notion of artificial intelligence and data scientists have been growing quite a bit in the last 5 years. As you can see, the AI trend has been going on since 2013, 2014, and accordingly, people start to look for data science, in-house data scientists to be able to combine the state-of-the-art research together with the business insights that they have. right? Now, interesting information about this chart. You might see that towards the end of this chart on the left, we're seeing a little bit of drop. And I largely think this is due to the coronavirus recently. It definitely has an impact on the world economy. But I think as the pandemic goes back, then we will see that online technology, online presences, and more smart algorithms is definitely even more needed than before. And we're going to be seeing a comeback of the need. And it is a perfect time for us to start thinking about how we stage ourselves and embrace AI technology once the pandemic is over. All right, so one thing that I really want to mention, since I'm in Alibaba Cloud, is that when we think about how do we deal with AI or deal with data and the next generation infrastructure, then we see that cloud provides a really good tools. Now, you don't really have to build all those kind of things from scratch, in the same way as you don't really need to build your own electricity generator, right? In Alibaba Cloud, we've been thinking about quite a lot of very similar problems. We've been thinking about how to build, smart public services. How do we deal with smart online merchandises? How do we deal with smart entertainment businesses and things like that? And those kind of practices enables us to build an infrastructure that can very easily provide the tools that you might need in building your own AI applications. When you are looking into AI for your own business, we can be helping and we can be handing you the right tools, the right infrastructures, the software and services that helps you to embed in the AI into your business. If you look back, then in providing much easier tools for us to understand business insights, AI is a very fundamental tool that enables us to bring our society to a much higher level. For me, I'm really excited and I feel really honored to be in this business. And as we are going through the digitization, I would say intelligentization, I'm not even sure that's a word, as we are seeing the world going to the next level and embracing AI more and more, me, myself, as an AI researcher and engineer, feel really, really privileged to have the opportunity to work on a cloud business and help you, and we'll work together to deliver AI to the whole society. That concludes my talk, and thanks so much. It's really great to be able to see you guys and talk to you guys during the pandemic, and hopefully it's over and we'll be working together very soon. Thanks, guys.